This is thermal physics, build up your understanding, question 37 from the book Pathfinder. So question is that in an old record found in lab, there is a process 1, 2, 3. So I have drawn it here. Over the time, so you can't see that which is pressure axis and which is volume axis. However, the descriptions given there reveal that state 1 and 3, so this 1 and 3, this lie on an isochore corresponding to volume V, right? So I've written that as V1. Amount of heat supplied during the whole process, 1, 2, 3 is 0. And the gas involved is 1 mole of helium. We have to find the volume occupied by the gas in state 2. So we have to find out the volume here. So let us see now. So it's given that in 1, 2, 3, heat interaction is 0. So that is what I have written. Now from first law of thermodynamics, delta Q is equal to delta U plus delta W. So delta U plus delta W is equal to 0, right? And even before that, this is volume axis, right? Now this is pressure axis. And how do I know that this is pressure axis? Pressure at 2 is more than 1 and 3 at more as 1. That you can find out, because now the logic here is that since from here to here, the entire heat interaction is 0. So if heat interaction is 0, that means delta W and delta U should have opposite sign. Delta Q is 0, so that means delta U and delta W, one should be positive, one should be negative. Now, if I assume that this is increasing pressure, then at 3 temperature will be more because volume is same. So if I assume that at 3 pressure is more as compared to 1, then delta U is positive, right? So delta W should be negative in that case. See, from here to here, delta W is positive, but from 2 to 3, delta W is negative. So overall work done is negative, right? So this is the possibility. That means this is possible, this pressure axis, and 3 at 3 pressure is more than 1. This is a possibility for this condition, right? So we'll explore that possibility and try to find the answer. So delta U plus delta W is equal to 0. So I have just calculated now delta W. So delta W is just the area of this area, right? Because you can assume this as a closed loop, and 1, 2, 3, there is no work done. So the area of this triangle I have found from base into height, right? So what is base? P3 minus P1. Here pressure I'm assuming as P3. Here it is 1. And then height is V2 minus V1. So base height by 2, but negative because overall work done is negative. Then delta W, delta U is very simple, NCVDT. So it is N. Helium is gas given is helium. It's monatomic gas, 3R by 2, T3 minus T1. So now after that, what I'm going to do, delta U plus delta W, I'm going to equate to 0. So delta U plus delta W, when you equate to 0, then delta W I've written as it is, and delta U, here I have written nRT3, I've written as P3V1. So nRT3 is this, right? PV equal to nRT. So that I have written as P3 times V1, right? Here volume is V1. nRT1 likewise I'm going to write as P1 times V1. So P3V1 and P1V1. Now you can just take P3 minus P1 common and you get V2 as 4V1. That is what we need to find out. Volume here as compared to the volume here. So volume here will be 4 times of the volume here, right? So it's a very good question. Exactly advanced level question. This question can come in advance as it is. So if you have liked this analysis, please hit a like button to this video and please subscribe to this channel also. Thank you very much. All the best.